All right, so good morning, everyone. We're just going to kind of do a quick run through the review to kind of make sure we're prepared for the quiz that I'll be posting along with this review today. I think this quiz is one of the easier ones I've given. Usually when I give this quiz, I ask that students don't use a calculator. I would challenge you to try that at home today when you're doing it. But I mean, obviously I can't monitor it. So if you need to grab a calculator, feel free. But I would recommend that you try and do it without a calculator first, and maybe kind of check your answers if you need to. The first section you're going to see on your quiz is just some exponent rule review. So kind of like when you're multiplying, what do you do with powers when you have power to a power? And then the zero exponent rule as well are going to kind of come up. So for this first question, I mean, you would just multiply, your coefficients. So it's going to be negative 30. When you multiply like a same base up to a power, so like x squared and x to the seventh, you add the exponents. So 2 plus 7 would be 9. I mean, really how you can think of it is if you have 2x's and 7x's, you have 9x's when you put them together. And then we have the y. So then that would be your answer. Nothing else you can do from there. The second question, you have a quantity up to a power, or we're going to have powers up to a power. Just kind of make sure you take each piece up to the second power. So 5 up to the second power would be 25. X squared up to the second power, that would be, remember, power to a power you multiply, or if you had 2x squared, you'd really have x to the fourth. Then that would be y squared. This third one, remember, anytime you have something up to the 0 power, it is simply 1. You could have a giant mess of stuff up to the 0 power, you're still going to get 1. So that'll be the first section, hopefully not too bad. The second section, you're going to simplify different types of radical expressions. This first one's pretty simple. The square root of 49 is 7. The square root of x squared would just be x. Oops, that's kind of sloppy. 7 times 7 is 49, and x times x would be x squared. Or remember with the variables, how many groups of 2 can you make out of 2x's? Because remember, this is a square root. The index number is 2. We just don't write it. But this would simply be 7x. For 5, anytime you see a decimal underneath a radical, it's definitely to your advantage if you change it to a fraction. You could use your graphing calculator feature. Remember, if you type in a decimal into your graphing calculator and press the math button, the first option will say fraction. So you could also do it like that. But one tip, here's how you would do this without a calculator. Remember your decimal place, it's tenths, hundredths, thousandths. So we really have 27 thousandths of a fraction. So that would really be 27 thousandths. So that would be 27 over 1,000. For example, if you had 10 hundredths, that would be 10 over 100, or so on and so on. But now this simplifies very nicely. Remember, with a fraction, you take the cube root of the top over the cube root of the bottom. So the cube root of 27 is 3. If you recognize that, the cube root of 1,000 is also 10. I don't know if you recognize, because 10 times 10 times 10 would be 1,000. So if you recognize those simplify very nicely. But you could also do a factor tree or try and pull out perfect cubes. For number 6, the fourth root of 64. So you want to see, like, I mean, you could do a factor tree, but I'm just going to think about perfect 4. So 1 to the 4th power would be 1. 2 to the 4th power would be, just make sure, 16, right? 3 up to the 4th power is going to be too big, right? That's 81. So 16 goes into this. So this would be the 4th root of 16 times the 4th root of 4, right? Because 16 times 4 would be 64. So really, if we simplify the number part, the 4th root of 16 is 2. The 4 is going to stay underneath our radical. And then we got to deal with our variable part. So m to the 7th, how many groups of 4 can you make out of 7? Well, 1. So if you pull out 4 m's to make that 1 on the outside, you would have 3 m's left underneath your radical. Because if you think about, I mean, like how I like to think about it, basically, if I was going to put this back underneath my radical, this counts as basically 4 m's, like if I put it underneath, because the 4th root of m to the 4th is m. And one thing I should mention on your test, I definitely want to see any work. I know some of these, like you can kind of do without like those exponent rules, for example, you pretty much could probably do a lot of those in your head without showing steps. But like a question for number 6, I expect to see the steps of how you're simplifying. For example, especially like the 4 through to 64, where it's not just like, oh, it's 2. Like, for example, I don't need to see work for question 4. I mean, I'm assuming you could just do that mentally. But this, I would like to see how you're breaking it down to like like if there's more to it. Next section, though, we're going to look at multiplication and division. Basically, remember, if you have division, you can just simply divide. If you have multiplication, you can multiply what's underneath your radicals, as long as they're the same type of radicals, like you have a square root and a square root, or a cube root and a cube root. That's the only thing really requirement for multiplication or division. So this one, if you divide, you would just get 4x, which if you simplify it, I mean, the square root of 4 is 2, and that x is going to stay underneath your radical. This one, we would want to multiply what's underneath. Multiply, use those exponent rules. So that would be x squared. This would be y to the third. Then we want to simplify. So like I said, I want to see your work if you're simplifying something that's not as simple. Like the square root of 12 just isn't a number. But remember, you could pull out a perfect square. This would be the square root of 4 times the square root of 3. So that would be a 2 on the outside. And we're going to have a 3 underneath our radical. For this x squared part, that would just be x on the outside. For y to the third, we could pull out a y, but we'd have 1 left over. So we would have 2xy times the square root of 3y. The next section is addition and subtraction. And just pay attention, explain if it's not possible to simplify anymore. So for example, this first question, and just keep in mind that that is a subtraction sign there. It might, I don't know how clear it is on your end, but that is 3 square root of 5xy minus 5 square root of 2xy. Remember, you can't add or subtract unless you have the same index number and if you have the same radicand or what's underneath your radical. So this one you cannot subtract because you have different radicands. So nope, different radicands. Make sure you state this. So, I mean, this doesn't mean like that there's like no, I mean, this is just our simplified answer. So that's one thing I want to make sure that's clear. Just because we say we can't do it doesn't mean like it's not, I mean, if we had like numbers, we could obviously plug it in and get values, but we can't simplify it anymore in radical form. Even if you change it to exponential form, you really wouldn't be able to do much with this, I don't believe. So I don't think you get anywhere with that. This next question, remember, if you have the same radicand, like what's underneath, and the same index number, you can simply add. So it's kind of like we have 8 of these plus 2 of these. So you would have 10 of those cube root of x squareds. So basically, when you're adding or subtracting, once you get, if you have the same radicand and index number, simply just add your coefficients or subtract your coefficients. All right, so that's kind of what the first page or so of your test is going to look like, or your quiz is going to look like. This next part, addition, we just kind of want to simplify these different problems. So like we said, we can't add these yet because they have different radicands, but you want to check, can you simplify these and see, do they get to have the same radicands when simplified? So since these are square roots, you could pull out perfect squares. This would be the square root of 16 times the square root of 2. Sorry, that's supposed to be 16. So that would be 4 radical 2 if you simplify that first part. This one would be the square root of 9 times the square root of 2. So that would be plus 3 square root of 2. So now that these have the same radicands and index number or same type of radical, you could just add these together. So that would be 7 radical 2. And you could show your work differently if you want to do factor trees instead of pulling out perfect squares, like by all means, but please make sure you're showing your work on these questions. Number 13, if you want to rationalize the denominator, remember you just multiply by the conjugate. to the top and the bottom, because then we're really not changing this problem, because remember 5 plus the square root of 2 over the 5 square root of plus over 2 is really 1. So we're really just multiplying this equation by, or this expression by 1. So if you simply FOIL or distribute the top, you would get 15 plus 3 square root of 2 on the denominator. You can FOIL, but remember one tip, your two middle terms are going to cancel when you FOIL a conjugate. So 5 times 5 would be 25. I mean, if you want, you could do plus 5 radical 2 minus 5 radical 2, but those are going to cancel out. Square root of 2 times the square root of 2 is just 2, so this would just be minus 2. Or if you could do that in your head, I mean, you would just have 15 plus 3 square root of 2 over 23. All right, the last few questions, this one here, they just want you to rewrite in radical form. Remember, the denominator is your radical, the numerator is your power. So remember, denominator of 2, that's a square root. We don't usually put it, I mean, if you want to put the 2 there, you can. But remember, I mean, you don't write that when you write a square root. Like, I mean, so I guess like an uppity mathematician might snub, like, I mean, look down upon you if you did that, I guess. But I mean, technically, there's nothing wrong with it. This one, we're given it in radical form. We want to just basically do the opposite of what we just did. So remember that inside power is going to be your numerator. Your index number is going to be your denominator. So these two questions, hopefully, are easy peasy, lemon squeezy kind of thing. Question 16. I know this one's kind of silly because I mean, I know you could simplify it because it's in exponential form, but the one on your quiz, you're not going to be able to just like add the powers. So just entertain me. So on your quiz, you're going to get a question where I want you to change it into radical form. And then see if you can simplify it from there. So like this question, if you multiply this out, 25 times 25 is 625. And then you just want to see if you simplify this, like you could pull out a perfect cube of 125. So like this would simplify to be 5 cube root of 5. But I know you could just literally write this as 25 up to the 2/3, and you could like even simplify it from there if you want. But these will have different bases on the question on your quiz. You're not going to have 25 and 25, so you won't be able to do that. So you're going to need to change it into this radical form. So how I showed you in this example is how you're going to want to look at the last question on your quiz. So I worked out the quiz. I think this is a pretty good basis. I think this might be on the easier side of the quizzes I've given. I could be wrong, but so I think this should be a pretty solid grade for most people. Most of these questions I am going to grade basically just on correctness. So please be careful. Just double check your answers before you submit it. But let me know if you have any questions. Feel free to give me an email if you're looking at something. But Friday, I will definitely be in class to answer questions if you need it.